client wants to see it, you push it to a server, and bam, your client tells you they don't like it. So the next step is the application structure. So this is commonly like a web front end API layer. This can be, REST endpoints, XML, God forbid, or it can be a database as the last layer. So there's 3 layers. Keep that in mind. I know it's a lot to remember. We have front end, API, and database. So the main thing I want to talk about today is application structure and where these mistakes can happen. I want to just make sure I'm not going to hit space on this thing and just everything's going to fall apart. All right, so Git. Git is the first topic of discussion. This is like the start of everyone's project, and it typically ends so wrong for people. So first things first, what is Git? Git is a utility software that tracks changes in files. This is a really great utility for what it does, and it is also really great if you want to expose your public secrets to the internet. So everybody's heard of Git recently. I don't know, maybe Shugit. Anyway, so Shugit's been in the news. What it does is it parses the GitHub API stream for valuable assets like usernames, passwords, config settings, just general things of mayhem, and then displays it in front of people. So if you want to know what that is, it's Shgit, SHHGIT. So that's a really cool utility. Check it out if you want to just find some creds on the internet. It's not illegal, I don't think. So, alright, so your 2 main issues with Git, your risk. It's going to be secret exposure and supply chain attacks. What is secret exposure? Secret exposure is when you, say, submit a public, a config file to a public repository. People read it, they grab your, say, Amazon keys, and they charge up like $1 million spinning up crypto jackers. Right? The next one, supply chain attack. What that is if somebody gets access to your code base, they can change your code, and then you may not even know this, but it will be then, shipped off to all of your clients or remote locations or, other things. This is the fun one, supply chain attacks. There was like a really famous supply chain attack like a long time ago where like the government poisoned the alcohol supply during Prohibition, killed a whole bunch of people. So that's probably one of the earliest versions of supply chain attack. It actually caused for the end of Prohibition, so if you are here and you come drink at the after party, thank the U.S. government for killing people. So, well, we're just talking about anyway. That's not why I'm here today. It's not why I'm here today, guys. Yeah. So, did I stop there? CC Cleaner, also another example. I want to thank David Freitag for telling me to speak about that, and that's as far as I'm going to go on that one. So, start of it didn't kill anybody. Alright, so you want to start every project off right. Use a Git Ignore file that's publicly available, right? When you create your first project, GitLab does this thing where it kind of gives you these commands for Git, and it's like, just do git init and then git add all. And the problem is the git add all, if you didn't have a Git Ignore file, you're going to add all your favorite stuff to the internet. And by favorite stuff, I mean API keys, secrets, log files, nudes. Alright, I have actually a lot more to say about this. So Git Ignore. Use a standard one. You can grab them from GitHub. They come completely available. So not only if you don't know what you're doing with the programming language, check out Git Ignore. It has file paths for the application technology you're using. So let's just say you don't know where config files go. In the Git Ignore file will be a path for configs. So, just use that as a way to structure your code base so other developers who are potentially going to work on your code will know where to also put things because you put things in the right structure. Not why I'm here. So, next thing. Another thing is that these can be used as treasure maps, these Git Ignore files. So if you are doing a pen test on a web application and you come across technology you can recognize or fingerprint, what you do is you look up the Git Ignore file for it and then enumerate those directories for secrets. Just simply typing in, I got the Qt one, I noticed that it has an object script of .release, do a quick file type for .release, wango bango, Bob's your uncle, we got passwords. So why is this better than just, say, searching connection string? Is because you're actually looking for .release files. So the release files are production files versus, say, debug files. If you were to type just connection string equals, you're going to end up with a lot of, code examples and templates and stuff for, tutorials. But if you look for the right type of file type, you know when you got a hit. So there actually isn't a username and password here. I did kind of block it out, but don't look at this one. So, let's continue. Before anyone takes a picture. Alrighty. Front end. All right, so your main front end risk. Again, why does secret exposure keep happening? Hey, this is my boss, guys. Everybody give a round of applause. Better late than never. So anyway, so front end. Your main issues are going to be secret exposure and cross-site scripting. Secret exposure, again, people seeing files that they shouldn't be seeing. Or, in the case of a front end, people saving properties or values to storage that shouldn't be there. So very frequently people think that maybe like local storage is secure or even secure cookies are secure. But always assume that everything can be read by the client. So therefore do not put anything there. Very easy way to do this is just use your front end as a presentation layer. That way there's no reason for secrets to be there. Let your API handle all the dirty business. So next we have XSS. Use a modern framework for these things. A lot of the modern frameworks, templating engines have a lot of built-in XSS protection. It is not a silver bullet. It will not protect you from really fringe cases, but we develop products quick, and like really, we're not looking for fringe cases. We're probably going to get maybe like the most of like 50 to 100 users on this thing, even in its prime run. So we don't really focus on fringe cases when we do development for, quick deployments. All right, so use modern tooling. Use things that's fully supported, things that are still being worked on. The really famous ones today are like React and Vue and maybe like Angular 2 if you're brave enough. Yeah, thank you. Thank you. All right. Simple, just presentation. I spoke to this. You want your front end to just be a presentation layer. You do not want to put business logic on your front end. You do not want to have anything that your back end may or may not rely on. Just presentation. If you only display stuff, it means less code, it means less bugs, less maintenance, less money, less time. Less code, the better. What are you saying? It's just be simple, right? So he's saying that he runs to developers and they can't seem to segregate the layers of business. It's really simple. If you just know your front end is just able to display stuff poorly, you are good. No secrets on the back end. Or front end rather. Nothing in local storage. Nothing in JavaScript files. Nothing in comments. Please. Don't make everything easy. Alright, so this is an honorable mention. Use HTTPS. If you're gonna, pretty much the only secret you should have being tossed around on your front end application is when the client inputs data and sends it somewhere. It should not be held on the front end. Use HTTPS just in case people are going to get nosy about what's going on. That's an honorable mention. That is not one of the biggest risks, I would say, when you're doing small layer development. API layer. So your biggest issues are going to be enumeration and unsafe data. What I mean by enumeration is if, say, you have an endpoint that ends in a database ID, what can happen is somebody can then enumerate through all of your database IDs and then get all of your information from the database. So you're going to want to protect against this. The next thing is unsafe data. Do not trust data from anyone. Barely trust it from yourself. Trust no one. Do not, don't even trust yourself on this. Don't trust your own database. Alright, UUIDs for everything. This is how you're going to protect yourself from enumeration. Use UUIDs for everything. File names, database IDs, your dog's name, cat's name, mom's name, UUIDs. Just, if I have a kid, it will be a UUID. Talk to me later. I would like to see that. John, you listening? This thing is lagging. Alright, don't trust client data. Again, don't trust yourself, don't trust anybody. Especially do not trust serialized objects. Let's say this again. Do not trust serialized objects. I do not mean JSON. I mean like bytecode, pickles, whatever .NET uses. Just don't trust it. Don't deserialize it and then run it. Don't. Oh, did I skip a slide? I don't know how to go back. No, we're good. Alright, databases. We're almost done, guys. How am I on time right now? 2:48? 12 minutes. That's all I need for everything. Databases, injection and unintended access. Anyway, databases, injection. You're going to be worried about SQL injection. I know, like, it's 2020. It's not something that really gets talked about anymore. So, databases. So, to protect against injection using ORM, I'm going to have more slides about this. Unintended access. This is not necessarily somebody getting your database credentials. This is also, like, say, a junior developer having root access, and maybe or may not deleting a table or exporting secret content. Right. Takes more than that. All right. Use an ORM. What are ORMs and why are they valuable? An ORM is an object relational mapper. What this does is it translates code into SQL. Why is this good? Because if you were to put regular SQL in your application, it would only work for that specific type of database. Replace it with an ORM. You could work on MS SQL, and your buddy over there could use MariaDB. What this does is it abstracts the code from the database, therefore making it platform independent. So there is no lag. It would only take like a configuration setting to allow somebody to either use MS SQL or MySQL. Using ORM, they do protect against a lot of the baseline SQL injections. This is not a silver bullet. Again, it just happened. We just had SQLize.js get hit, and that was a pretty easy SQL injection. Luckily, most people adhere by my policy of don't put secrets on the front end, right? So I'm sure there's no SQLize.js vulnerabilities on the internet anywhere. I'm sure of it. Alright, no application should use the root account. Say it again. No application should use the root account. Every account that uses your database should be specific for that application. That means that if your application does not have a need to write to, say, the users table, do not allow them to write to the users table. Allow them only read access. Did you know that you can actually lock down specific columns to a table to a specific user? So if you had, say, regular access for an application, you could prevent that application from reading, say, a really sensitive file like the password hash. So keep that in mind. Next slide, definitely about no users using the root password. No developer should have this account. If no developer has this account, they cannot export data, they cannot allow it to be stolen, and they could not break things. No developer should use the root account. Ever. Ever, ever, ever. Only one person should have it, and in case they die, that's it. Use standard encryption for passwords. This does not mean roll your own. Again, don't roll your own. What does this mean? Use bcrypt. Use something standard. Do you have a question? Versus what? Alright, I'm not here to discuss that. That's an interview question. If you're taking interviews later. So, oh, so you're actually right. It should be hashing, right? Use standard hashing for, yeah, I get it. Because bcrypt is not reversible, right? I don't know. Doesn't matter because you should use a standard one. Use it. They got it. I don't need to know about it. That's the whole point of this. You don't need to know about it to use it. Just use it. I'm a developer. I don't got time for this. Nothing executable in the database. Do not store SQL in the database. Do not store HTML in the database. Do not store JavaScript. Do not store Python. Do not store Ruby. Why? Because if somebody gets access to your database, they may only have access to your database. But if they find a nice, sweet Ruby script in there, they could change those values, and then hopefully at some point it will be executed by your application. That is how you go from having a low-level access violation like a database to a higher level one like a remote code execution on a server. Do not put executable stuff in the database. Oh, especially don't put even display properties in the database. Like if you want something to be read on the front end, don't put the property read in and then pass it in as a method to the CSS. Don't do that. It's unnecessary. Also, it's really weird later when you have a million records that are supposed to be green and they're all red, and then you have to update a really large table just to change a display property. Otherwise, what you could do is put in the code if red equal green, and then everyone's confused later. So, I don't know why the alert's supposed to be red. Deployment. I actually left this a lot of this stuff out because there's a guy here who did a DevOps talk earlier that I sure would have way better content than this. The only thing I want to stress is nothing manual. Nothing on your local machine. If you want to do something like have a script that builds it somewhere else, that is the ideal thing to do. Nothing manual. Do not build it on your own machine, especially, and then ship it out elsewhere. Everyone's heard the expression, works on my machine, right? Well, that's because your machine has an environment that's specifically catered to it running in your local environment because you're the developer and you made it run. Now, you build it on your local machine, ship it off somewhere, and it doesn't run, and you don't know why. What'll happen is if you do this somewhere else on an isolated machine with a script or like a platform like Jenkins or CircleCI or any of the other ones, it'll give you a quicker identification that something's wrong. And it also like kind of creates a more clandestine or like, sanitized environment for developing these, for deploying and building the applications. So that is my talk. I did not put a thank you slide in because I am a heathen and don't care about anyone. So, I want to just say thank you to the organizers here. Thank you for coming here and listening to me and spending your time with me. Thank you, John, for showing up. Just give a round of applause for my boss. He's awesome. So thank you guys. Thank you, Grandma. If you're watching, how did this get on TV? Love you guys. Special thanks to everybody here again.